Okay, so today we're going to talk about conditional statements. Conditional statements are a formal way of writing conjectures. It's a little easier actually because you're not like just having to start from scratch. It's in a format so you can, when you're writing a conjecture, you can have like a guide to use. So a conditional statement is always in the form of if, then. If something, then something. If it's rained every Friday for the month, then it's going to rain next Friday. That kind of thing. All right. The symbols for conditional statements, and if you go to a liberal arts college, I guarantee you'll take discrete math, which is like the logic of statements and reasoning, and you use these a lot. The P always stands for the if part of the conditional statement, and the Q always stands for the then part. So this would be read if P then Q. Okay? On the Venn diagram, ordinarily you would see a Venn diagram that looks like this, right? Like all the information in the first circle and all the information in the second circle, and then the stuff they have in common is in the middle. Well, in an if-then statement, in the conditional statement, you're testing if something's true, then it belongs to the big Q group. So instead of having two interlocking circles, the if part is completely contained in the then part. Okay, and I think it's easier to see with an example. So let's look at this example of a conditional statement. If the animal is a cardinal, then it is a bird. So you've got the P, which remember goes with the if. So you say if the cardinal is an animal. So cardinal would be the if part. And then birds would be the then, the Q. So it would be on the outside. Okay, so you're looking, you're saying, okay, if this animal is a cardinal, so you're looking, you're judging whether it's a cardinal. If it is, then it's a bird, then it belongs in that group. So cardinals are a subset of birds. All right, and then vocabulary-wise, we call that if part the hypothesis, the thing that you're testing. Is it a cardinal? If it's a cardinal, then. So that part is the hypothesis, the P, the part that comes after the word if. And the conclusion is after the then, the group it belongs to, what you can do once you judge your hypothesis. So it's Q, and it comes after the word then. All right? And Pioneer Pete's so clever. He came up with he wrote the definition of conditional as a conditional statement. He said, if it has a hypothesis and a conclusion, then it is a conditional statement. See, he's so clever. All right, so I want to come up and put the pink, see how I kind of heard him here, the pink over top of the hypothesis and the green over top of the conclusion. Okay? All right, try it. Right, exactly. If today is Thanksgiving Day, so that's the hypothesis, then today is Thursday. All right, and if we're going to write the Venn diagram of that, it would be if today is Thanksgiving Day, so Thanksgiving Day would go in the smaller subset circle, and then today is Thursday, that would go up here. Okay, and it makes sense. All Thanksgiving days are Thursdays, right? You couldn't do it the other way. You couldn't say all Thursdays are Thanksgiving Day, because then tomorrow would be Thanksgiving Day, and it's not. So that wouldn't work. Okay. All right. Somebody come up and do the next one, and be careful because it's a little bit trickier. Okay. Right. You know that this is the hypothesis because it's after if. Even though it's coming at the end of the sentence, it's still after if. So if it is an integer, then the number is a rational number. Okay, and the Venn diagram of that would be integers on the inside, the if part, the P, and then rational numbers would be outside. Okay? Integers, rationals. Integers are part of the rational number group. All right? Now let's try writing the conditional statements. The way I would suggest, if it's not automatically flowing, go ahead and draw your Venn diagram first. All right? So if I had to pick the two words that would be the key words, like cardinal and bird up above, or rational and integer, what would be the two key words? Right, midpoint and bisector. Okay, which one is the larger group? What can you take the midpoint of? This is segment. And what can you take a bisector of? Well, a segment, an angle. Well, right there, it tells you I've only got one thing for midpoint, and I've got two things for segment, or for bisector. So bisector must be the larger one. So when I draw my Venn diagram, midpoint is going to be the smaller one, and bisector is going to be the larger one. So take a minute and write the if-then. Okay, good. So if and the if part is the midpoint. If M is the midpoint, then, and the bisector is the then it is a bisector, or then it bisects the segment. Okay? Let's try the next one. Adult insects have 6 legs, and no other animal has 6 legs. So which is going to be the smaller group? The animals that have 6 legs or adult insects? Right, adult insects. So the larger group is going to be adult insects, and the smaller group is going to be the 6 animals that have 6 legs. Okay, so take a minute and see if you can write. Okay, there are 3 different kinds of conditional statements rather than the regular old basic kind. There's 3 more kinds. And before we talk about them, you have to talk about negation. Negation, think of a word that sounds like negation to you. Right, negative. And negative, that's what negation is. It just makes whatever you're saying negative. And the symbol for that is this little tilde, little swirly thing here. Okay, so like for instance, if I have a conditional statement, M is the midpoint of AB, the negation would be M is not the midpoint of AB. It just takes the original statement and makes it negative. Okay, and that symbol again, that little squirrely thing. All right, so that's a negation. We're going to use that now to talk about the different kinds of conditional statements. The first one is a converse. Okay, converse is when you take the hypothesis and make it the conclusion, and take the conclusion and move it to the hypothesis. You're basically flipping it. Okay, so if my conditional statement is if an angle is obtuse, then it has a measure of 100 degrees. What's the hypothesis, right? And what's the conclusion, right? Okay, so we're taking the converse would take the hypothesis, an angle is obtuse, and make it the conclusion. So then it is obtuse, and it takes the conclusion, it has a measure of 100 degrees, and it makes it the hypothesis if an angle has a measure of 100 degrees. So the pictures of it would look, the symbols would look like this. Instead of if P then Q, a converse would be if Q then P. Okay? And your converse statement would be if an angle has a measure of 100, then it is obtuse. You just flip those. Okay? Now an inverse is where you leave everything in the same order. Hypothesis stays hypothesis, conclusion stays conclusion, but you negate them both. Okay? So in symbols, it's if not P, then not Q. Remember, this little squiggly means not. So you're leaving them in the same order. If an angle is obtuse, then it has a measure of 100 degrees. So you're leaving the angles obtuse first. You're leaving a measure of 100 degrees second, but you're making them both negative. So if an angle is not obtuse, then the angle does not have a measure of 100 degrees. So it leaves it in the same order, just makes it negative. Okay? Now, so converse changes the order. Inverse negates your statement. Contrapositive, I know, big word. Take a second, write that down. Contrapositive switches the hypothesis to conclusion and negates it. So it does both. It does the converse and the inverse together. So if my original statement is, if an angle is obtuse, then it has a measure of 100 degrees, my contrapositive would be, if an angle does not have a measure of 100, so again, I switched the hypothesis and the conclusion, and then the angle is not obtuse, and then I made them both negative. So I took the hypothesis and made it the conclusion and made it negative, and then I took the conclusion and made it the hypothesis and made it negative. Okay, so let's try and practice a little bit of this. Okay, so my original statement is, if the measure of angle A is 95 degrees, then angle A is obtuse. That's my original conditional statement. Converse, which switches the hypothesis and the conclusion, would be down here. It would take the conclusion to make it the hypothesis. So if angle A is obtuse, then the measure of angle A is 95. So that's this one. Okay? The inverse, which just leaves it in the same order but makes it negative, would be if the measure of angle A is not 95, then angle A is not obtuse. Okay? And that would be that one. And finally, for contrapositive, we're going to switch the order and make it negative. So I'm going to change, it's going to be if angle A is not obtuse, then the measure of angle A is not 95 degrees. And that will be that one. All right? All right, so your homework